There we go. All right, we are live. Sorry for the delay, everyone. Welcome back to HashiCorp Live, affectionately known as Not Ready for Production. And I do mean that affectionately. I am Tracy Holmes, developer advocate here at HashiCorp, and I am nervous. I apologize, but guess what we get to do today? We are going to dive into the what's and whys of provider development with two of my favorite people at the company, Katy and Paddy Carver. You all want to say hi?
Hi there, I'm Katy Mo. I'm a senior engineer on the Terraform Plugin SDK team.
Hi, everyone. I'm Paddy Carver. I'm the engineering lead for the Plugin SDK team. I use he, him pronouns. Hi, Terrafam. I've been waiting to say that. I've been like,
waiting to say that.
I've been waiting for my opportunity to say, hey, Terrafam, when nobody can stop me because we're streaming live. This was not well thought through.
This is very indicative of the rest of the stream, everyone. We also have the man behind the curtain, Tony Carmichael, product manager for Terraform, and he will be in the chat. So you'll get a couple of answers from all sides today. So you all know about providers. And for Terraform, we have a team dedicated to just that. So providers like Azure, Kubernetes, VMware, that kind of stuff. Well, we also have another team on the open source side, and it's called the enablement team. And guess what they do? They enable you to do all the things. So, for example, the enablement team works on the language server, which some of you all know about. Well, another portion of that team is the Plugin SDK team, and that's where Katy and Paddy are. So, before we get started, I saw a question on the Terraform subreddit today. And so with that in mind, we might have some viewers on here that are not quite familiar with provider development. So I want to ask a question on their behalf, and I'm included in this. We always see the terms providers, plugins, modules, that kind of thing all over the place. So at times they seem interchangeable. So what exactly are the differences?
Yeah, so this is a good question, and it's understandable even if you're familiar with provider development to ask the question, well, if I can only make a Terraform provider with the Terraform plugin SDK, why did you call it that? So we have, on the one side, we have Terraform plugins, and Terraform plugins are providers, provisioners. At the moment, you can only use the plugin SDK and plugin Go, as we're going to show you, to help you make Terraform providers. But in the future, we're planning to expand that to more plugin types. Modules, on the other hand, so Terraform providers are made by Terraform provider developers. Hopefully, some of you are here today. Terraform modules are collections of Terraform configs, which can be distributed easily. And they're made by Terraform practitioners. So you're writing an HCL, you're writing some Terraform config files and collecting them into a module. So that's the difference between those three things.
So Go's on one side and modules have HCL on the other side, basically.
Yeah, exactly.
Got it. All right, cool. Well, that in mind, I'm going to let you all get started.
That's my cue, and I couldn't find my mouse to hit the unmute button. And this is just how this stream's going to go today, everybody. I hope you all be gentle with us. We're going to be showing off some code today. We're really excited about it. But also, bear in mind, this is all toy code that we wrote like in the last week, in addition to doing our other jobs. So you may see bugs, you may see things that break. This is, yes, hashtag not ready for production. So I hope you all be gentle with us. Today, we want to talk a little bit about two new packages, two new libraries that we've released in the last few weeks, Terraform Plugin Go and Terraform Plugin Mux. And these are new modules that we've created for Go provider developers to integrate with Terraform in a different way than the Plugin SDK allows. The Plugin SDK is a 6-year-old library that has really powered Terraform's growth ever since its introduction. Terraform 0.2.0 is kind of when we introduced the helper schema framework for provider development. And Terraform's changed a lot in that time. Helper schema hasn't always changed with it. And so the abstraction isn't always perfect for the concepts that we're talking about. And we're going to show you a little bit of that today. And so sometimes Terraform's features are locked away because you can't get to them from the SDK. There's no way for us to expose them in the SDK without breaking everybody. And we don't want to break the thousands of providers that we've got in production already. We have thousands of providers. I think the AWS provider alone is like 500,000 lines of code. Like there's a lot of time and effort behind all of this stuff. And so we take changes to the SDK very seriously and try and make sure that they're going to be backwards compatible and that, you know, we're not breaking everything on everyone. So we developed kind of these new modules as a way of saying, okay, but like, what would provider development look like if we got the SDK out of the way entirely? What would happen if we let you just go, I call it bare knuckling the Terraform protocol, because you're not using like an SDK or anything. You're literally just interacting directly with the protocol for Terraform. And our answer to that is Terraform Plugin Go, and Terraform Plugin Mux is how we're going to bring Terraform Plugin Go to our existing ecosystem. And we're going to talk a little bit more about those as the stream goes on. But we're really excited because this is part of our vision for the future of provider development. We kind of spent this year deciding what provider development should look like, what modern provider development looks like, and how we can kind of improve the provider developer experience to make it accessible to way more people than it is today. And so we spent all this time doing that, and we've got like a long-term vision of it. We have goals, but our very first steps are to kind of get the SDK out of the way and let you get to the full power of Terraform. And that's kind of what we're trying to do with this Plugin Mux and Plugin Go library that we released a few weeks ago that we're going to kind of share and show you a little bit more about today. I think I've talked long enough. I'm just checking to make sure I said everything I wanted to. I think I did. Cool. I think that's everything. With that said, do we want to talk about, oh, I'm sorry. I am supposed to call out. For those of you not already familiar with building a provider, the stream's going to be a little bit difficult for you to follow, but we'll do our best. There is a Learn guide, and we'll drop a link in chat for that to teach you kind of the intro to Terraform provider development. These tools are for advanced Terraform provider developers though, so this might be a little bit tricky for you to follow if you're not familiar with existing Terraform provider development practices, but we're going to do our best. With that in mind, do we want to just jump right into our live demos then? Katie, do you want to take over?
Yeah, let's go for it. Yeah, okay. I'm going to share my screen. I assume you'll let me know if that doesn't work. Actually, I noticed when you said, Paddy, you mentioned modules there. We've also got the concept of Go modules. So you've got Terraform modules and Go modules. So just to be clear, what we've released are Go modules here. So there's another concept to confuse everyone.
Yes.
Yeah, so,
just in case
we're kind of hoping that people familiar with Helper schema and the existing plugin SDK will get a lot out of this talk, because the structure we've sort of thought about for it is that we're going to show you a demo provider we've made with Helper schema. We're going to show you some limitations of what you can do with the existing framework, and then rewrite some of those resources in the new Terraform Plugin Go module, and show you how to use Terraform Plugin Mux. And that should hopefully show you how you can use more of the capabilities of Terraform with the new modules. So we've created this provider called DadCorp. Now, DadCorp is an alternative universe in which the other founder of HashiCorp, Armin Dadgar, got his name on all the products instead. So instead of HashiCorp, we've got the DadCorp provider. Thank you, Paddy, for this wonderful name.
Nice.
So I'm just going to like show you, I'm going to show you the sort of API we've designed, but the real point here is the providers. So we've essentially got an API which is based on a cloud service. So in this cloud service, you can have Vault clusters, Terraform workspaces, Console, Nomad. All of these have access policies. So for example, your Terraform access policy, which you can think of as like a IAM or profile or something like that. Your Terraform access policy might be different to your Vault access policy. And as a user, you want to be able to set the appropriate one. So in our API, we're returning these things as JSON, and essentially our API is just sort of set up here so that it will be a standard kind of JSON API. The provider itself, and we've got an API client as well, which our provider is going to use. So this should be sounding fairly familiar to those already familiar with helper schema provider development. So here's our helper schema provider. It looks fairly standard, I hope. So you instantiate your provider itself has a schema, and here are all the resources. So we've got some data sources here. The data sources are just those access policies I told you about. So later we're going to do some fun stuff with those. So for example, we have a Nomad cluster resource here. And as you can see, we've set up the schema in the usual sort of helper schema way. So you've got some strings, some Booleans.
Katie, not to interrupt her, sorry, really quick, but the chat is asking if you can increase the font size a little bit.
Thanks for that.
About to ask you, thank you. Paddy, and bump yours up, I guess, just in anticipation. Never back on.
So please let me know if this isn't okay now at this point.
No, that looks great. Thank you so much, Katie.
So my buffers might be in different font sizes for various reasons. Well, I mean, that's pretty much all I had to say about the existing provider. So this is the sort of basis that we're working on, and we're going to go through several different resources. And yeah, Paddy, do you think we're ready?
I got one of those Windows like admin interrupt alerts right at the same time you asked me that, so I couldn't unmute and tell you. I am preemptively bumping my font size up a little bit. Give me like 1 second and I should be able to get back to you. Give me like doing it live. Okay.
Meanwhile, I can tell you that we've got, of course, since we're good demo provider developers, we've written full acceptance tests for this provider. And just in case you want to see the test passing at this point, we will run them. So as you can see, all the tests are passing in this helper schema provider.
I love that you say that before they actually pass, because you've just jinxed us. Like, we are set to...
It'll either be successful or be really funny, right? Like if they fail at this point.
I feel like that's my career. My career in a nutshell, either successful or really funny.
Okay, that's your cue, Paddy.
That's my cue. All right. Mm-hmm. On the note of being successful or really funny, we're gonna try and have Paddy drive for a minute here. I'm gonna move this down a bit so you all don't. There you go. Can you all see that? Okay. I'm gonna assume you can until somebody tells me otherwise. And I need to catch myself up on where we are here.
Okay in the chat, Paddy.
Oh, everyone's saying it's good. So yeah, we've talked a little bit about getting the SDK set up with the resources. Now we're going to talk a little bit about Terraform plugin mux, which Katie, I believe, is the next thing we wanted to talk about, right?
Yes, it is.
Okay. This is super fun. So first we're going to talk about Terraform plugin mux. And Terraform plugin mux is basically how we're going to integrate our new provider development stuff into our existing provider. So we've got, as Katie mentioned, we've got a whole bunch of stuff written here. There's all of these files. There's all this code. I spent a long time on it. It's like 2,000 lines of code. I don't want to throw this all out, and I don't want to rewrite it all at once, right? We've got like 5 resources and 4 data sources, and like, I don't want to have to rewrite all of that in one big bang. So instead, we're going to work on what we call Terraform plugin mux. And I actually just want to show what the difference here is, because Terraform plugin mux is a way to set up different provider implementations. So you can have a helper schema server, and you can have a Terraform plugin Go server, and you can put them in the same provider. And Terraform mux will figure out which provider to send requests to based on which resource the request is for. And so to add Terraform plugin mux to your, first you need to figure out type, but to add Terraform plugin mux to your provider, it's actually a really straightforward process. And I know it looks very scary when you look at all of the dependencies that are pulled in, but that's how dependencies work, I suppose. The actual code that you need to change is changing how you call your tests. We have a different test prototype or a different test property that you supply your test providers to. You need to change the format of your test providers, and you need to change the main function that your provider is standing up. So here's the main function. Instead of calling into plugin dot, oh, sorry, this is the test. The test just kind of combines using the TFMux new schema server factory. This, I have no idea if I'm going to be able to highlight. I can highlight. That is very exciting to me. You can use this TFMux new schema server factory and you pass in the different provider implementations. So right now we're just adding mux. All we're doing is adding mux to the existing provider and changing nothing about it to prove that mux is working and it's all fine. So in this case, we've got the SDK v2 provider. It's getting passed into mux over here using new schema server factory. And then this is now a provider server that will route requests to either SDK v2 or SDK v2, because SDK v2 is the only option. That'll get more exciting in a minute, I promise. So there's that. And then main is basically the same exact, we have a few more test updates. And then main is basically the same exact code, because this is, again, just combining them into a server. And then you're calling this tf5 server.serve function here to start actually serving that. So that's the entirety of it. And that's all it takes to get plugin mux up and running. But what mux does that's interesting is it receives requests, and there are different kinds of requests. There are provider requests, there are resource requests, and there are data source requests. And they all get sent to the provider. And then the provider kind of farms them out to resources, data sources, or handles them themselves. But what mux is mux is a server that passes the provider functions onto other providers, and then it looks at the resource name of the request. And if the resource is a resource in the schema for a provider, it passes it on to that provider. Resources can only be in one provider schema. So for example, when you call get schema on, the SDK v2 provider, it's going to say, yep, I support these 4 resources. And when you call it on the Terraform plugin Go one, it's going to say, I support this one other resource. When you send requests for the other resource, it'll go to Terraform plugin Go. When you send requests for the other 4 resources, it'll go to SDK v2. And it all just works, and you don't need to touch any of your existing resource code. And that was like a hard constraint we had when building this, is we had to have a way for people to use all the new stuff we were building without needing to touch any of their resources at all. And so we're really proud of how we managed to kind of get that, to achieve that and get the user experience of that for our users, so that they could upgrade, use the newest and latest stuff. All of their new work can continue to happen using the latest and greatest software we can give them. But all of the old stuff will continue working exactly as it always has, because it's the exact same code. So we're really excited about the compatibility story that offers us going forth. I'm scanning chat. I cannot read and talk at the same time, so I'm just going to keep going on.
The question that's in there, the question that's in there right now is about HashiCorp verified status, and I punted that one to Tony, so you should be okay. Perfect. The answer to the HashiCorp verified status question is you should ask Tony, because I know nothing about that. So that's outside my wheelhouse. But cool. So I do want to move on really quick and just check out demo 2. It's very nice having Git tags to walk through this, because you do not want to watch me type all of this like live. We will just be watching me type for the rest of this. And this is now what we're doing is we're updating the provider to use Plugin Go as well. So we're adding the Plugin Go server to the Terraform mux, so that the provider now has 2 servers behind it. The Plugin Go server, it's not going to expose any resources at all, but it will give us the foundation to start moving resources over one at a time. So let's take a look at that really quick. If we look at Plugin Provider, Plugin Provider is a TF Proto v5 provider server. This is the equivalent of a Terraform or a helper schema dot provider. It's the provider server. It's the gRPC server that Terraform's going to call for your provider, and how it's going to get information about your provider and ask your provider to do things for it. Now, Terraform provider servers don't use the usual CRUD or helper interfaces that you're used to from helper schema. They actually use a series of RPC requests, and there are a whole lot of them. We'll drop a link. There's like a resource object lifecycle doc in the Terraform repo that explains all sorts of stuff about how the Terraform lifecycle and like
protocol works, but there are also docs in there about the protocol and stuff like that. We'll drop a link to those in chat. That's always really interesting reading, and it's not stuff that it's easy to find, but you learn a lot from it. Get provided schema, for example, this is going to return our schema, and it's actually a function call. It's an RPC call that Terraform makes. It says, hey, provider, I need to know what your schema is. And the provider returns like this schema RPC response here. And in this case, our schema for our provider is just a password and username. Both are optional, both are strings, not a big deal. Prepare provider config is bizarre, and we're not going to talk about it too much today, but it's a Terraform 0.11 compatibility thing where Terraform 0.11 providers, to continue their backwards compatibility, needed to have the ability to prepare the provider config before it was validated. So this gives you an opportunity to modify the config before it gets validated. It's very bizarre. Most people won't use it. It's probably fine. A constraint of MUX is that only one provider server can respond with a prepared config. That's why this is explicitly set to nil here, because helper schema is our one provider server that's going to have a prepared config. Configure provider works just like the configure call that you get for your provider in helper schema. It gives you some config information like that, and it expects you to kind of get a provider client all set up and ready to use, which is what we're doing here. You'll notice very quickly, first of all, that it is very much more verbose. That's what happens when you drop down lower to the protocol, is you have to repeat yourself a bunch more. We specifically and purposefully did not try and reduce the verbosity of this by adding helpers and stuff. There were, as I was copying and pasting, there were a lot of places where I was like, I really should just put this in helper, but we really wanted it to be clear what was part of plugin Go. So we didn't want to add any helpers on top of it. So you're going to see a bunch of stuff here that looks really scary. I promise with like 4-line helpers, a lot of this goes away and becomes less intimidating. But we wanted you to see exactly what was happening and not have to understand our helpers as well. So we've got all of this going on. You'll see very quickly that there's two kind of patterns. You get what's called a dynamic value off of the protocol, and a dynamic value is just a collection of bytes, and that's it. And that's not super fun to work with. So configs, states, stuff like that are all these are dynamic values. We have an unmarshal function on them that you pass in a type for, and in this case, it's a tftypes type, which I'll talk about in a minute. But you pass in a type and it gives you back a tftypes.value, which I will also talk about. There is a new package called tftypes, which exposes Terraform's type system. tftypes.object is an object in that type system. It's got objects, maps, lists, sets, tuples. Unlike helper schema, this actually has a formalized type system that is exposed that matches Terraform's type system, which means you can do all sorts of wacky, different complex types that you couldn't reliably do in helper schema because you were never quite sure how it was going to interact. If you want to do an object of lists, of sets, of tuples, of maps, of objects, of strings, I mean, be my guest. It's going to be a little bit tricky to use, but have fun. It should all work reliably. So that's very exciting. So object, this is just a way of describing the type. Objects have attribute types. Attributes are the different attributes in the object, username and password in this case, and they each have a type string in this case. Values are a combination of a type with some data. So when I say I'm getting a value back here, all it is it's saying I've got a Terraform value of some type. It's got a type and it's got some data, but that's all I know about it. To get values into being something useful, we use this .as function, which converts values into Go types. And in this case, the Go type is a map of string of values, which is how objects are represented. Why do we keep using values all over the place? I really wanted them to be Go types. I really wanted this to be like .as in map string string, and you get a map string string out of it. Unfortunately, Go's type system doesn't map well to Terraform's type system. Terraform's type system has the concept of an unknown value, which is like, I don't know what value this is going to be. I know what type it's going to be, but I don't know the value yet. And Go's type system has no way to represent that using built-in Go types, unfortunately. So that's why we've got to wrap everything in values so that you can check whether things are known or unknown, which we do down here. For example, this is checking to make sure that the username is known. We can also do nulls now. You can actually check whether something is set or is not set or set to the empty value. That is like a distinction you can make now, which I know sounds like a little thing, but after 4 years of working with helper schema was music to my ears. I was like, oh, that's everything I've ever wanted in the world. So I'm very excited about that. But so yeah, it's this recursive loop of going through and getting these values and just turning them into Go types. And so you can see all that happening here. You can see us returning diagnostics, nice error messages. They give users good context on it. I'm running over my time here in this a little bit, but and then we get into resource methods. Resource methods are going to be like validating, updating, planning changes, reading resources state, and applying changes. All of those RPC calls, and importing resource state. All of those RPC calls go right to the provider's level method. And so in theory, you could implement all of your resources and your provider in a single file. I'm going to highly recommend you don't do that. So what we're doing here is we're going to switch based on the type of resource it is, and we're going to call out to apply resource change functions for those specific resources. So we don't have everything all in one function, all on top of each other. And then data sources also have validate and read as well. I'm just going to check here that I talked about all the thing. Explain the type system. I did that. We explained how Plugin Go servers work. I think that's everything. So I think I'm going to pass it back to Katy now that I've talked myself hoarse. And I'm going to take a break. Katy's going to show us a little bit about transitioning our first resource to use this new foundation that we've set up for ourselves. Oh, there's one thing I want to do before. Oh, nope, Katy took it.
I'm sorry, I've stolen your screen.
No, you take it. I was just going to run a Go test, but it's fine. Go test works. Just take my word for it.
Yeah, just trust us.
Let's see. Let me go back through the questions because I said one out loud and forgot to go back to the other. So Rosemary asked, slightly tangential, basically, how does one write a provider with language other than Golang? Paddy responded, one does not. The TLDR is basically, while it's possible to write a non-Go, Terraform uses gRPC protocol, so it makes it harder than you probably want it to be. There's a best practices doc that was linked in the chat for that. The answer to the how does one become HashiCorp verified, the TLDR on that is you got to be a partner, but also if you're interested, there's an email address that you can contact for Terraform registry to find out all the ins and outs and the good stuff about that. Let's see, the next question was on my way, although I think I need some clarification on it. As a TF practitioner, it's super helpful for me to have integration tests against those Terraform resources. Do you explore outside HashiCorp tool sets such as Chef's Inspect and maybe even encourage people to write custom inspect resources against those custom Terraform resources? And so Rosemary responded, you could use inspect to write acceptance tests. I need water. Similar to the Terraform provider testing framework that Paddy's been showing, but you could also use them to do end-to-end testing, which would happen with more complex systems. Rosemary doesn't believe there are plans for Terraform to trigger these natively, such as Paratest and the like. And those are all the questions that we have so far.
Great, thank you, Tracy. Yeah, the testing is a really interesting one, and we're thinking about this at the moment, actually, because I mean, the question is, like, well, what are we testing here? What's the boundary between the Terraform system, the Terraform provider, and any other systems you might be interacting with? So, like, that's a really interesting question. I think we should look into that further at some point. So, great. Yeah. Okay. So I'm gonna show an actual concrete issue that we currently have with providers implemented in helper schema, and then how we can basically solve that by rewriting in Plugin Go. So I mean, like, actually, to go back to the question about other languages, you can implement a provider in another language. All you have to do is fulfill the specification of the gRPC protocol in the proto file. And in order to help people do that in Go, we have written this entire Terraform Plugin Go framework. So the amount of work you have to do is sort of equivalent to making this sort of framework. And as you'll see, the code you write in the provider does end up being quite verbose as well. So you can do it, it's just a lot of code. Right, okay, so
To jump in on that point really quick, sorry,
Yeah, please
Katie.
do.
There are also, like, I think at least 2, possibly up to 4 separate libraries that are written in Go right now. You're going to have to re-implement yourself before you even get to writing the gRPC part itself. Because, for example, we use message pack encoding on the wire, which you're going to have, which is a Go specific encoding format that you're going to probably have to re-implement for your language. You're going to have to re-implement the entire type system to be able to make sense of what those types are. There's a lot of work around it. And right now our focus as a team is trying to make the Go development experience as best as we can and trying to get that matured a little bit. And so we've tabled talking about we've tabled exploring developing providers in other languages, even though we know that's something people want, until we get a little bit more of a mature Go development experience for what we're looking for. So that was my little addition there, but I'm going to let Katie go and drive again.
Great, thank you. And during that time, I remembered that I hadn't done the Go install that I wanted to do before this section. So, okay, right, okay. So let's take a look at one resource called DadCorp Vault Cluster. So I hope this font size is big enough for you to all to see. So I mean, this is hopefully a familiar resource to people who've used cloud providers. We're making a cluster and we put it in some sort of region. So these regions are basically offered by the DadCorp service. Now the DadCorp service, as a thriving business, is always expanding the number of regions it covers. But currently, in order to validate this region before you apply your Terraform config, we're going to have to hard code the valid regions into our provider. So with the helper schema provider you can currently make with the current SDK, you basically have to hard code if you want to validate your config such that this region can only be a certain number of values, you have to hard code those values into the provider. And that's because during Terraform validate, due to some, whoops, of course, due to some historical limitations with how these things work, you basically do not have an authenticated connection to your API at the time of Terraform validate. So if you validate it now, it's valid as you'd expect. But now let's try putting in an invalid region. So US 29. If we run Terraform validate again, it will say that's an invalid region. Okay, fine, yeah. However, perhaps DadCorp has actually added this region. Actually, I think the one we wanted to use was London, which I'm happy with. I approve of that. Let's change it to that. GB Lon 1. Yeah, so I mean, maybe DadCorp has added this region, but we don't have the new version of the provider, so we can't use it. So at this point, we're just at a limitation in the current SDK. However, through this one Git command, I have implemented a new resource in Terraform Plugin Go. So let's just take a quick look through the Git diff to see what that actually involved. And I do need to warn you, it's quite a lot of code. But as you'll see, a lot of it is sort of boilerplate, filling in the sorts of methods that Paddy was describing before. All right. Okay, so the first thing we're doing here, so if you remember from what Paddy said, we've introduced this muxed provider idea. And that basically just means that we can field requests for resources in either the old provider or the new provider, the old SDK provider or the new Plugin Go provider. So in this case, in our plugin provider, we've just added that resource to the resources that provider is responsible for. So we're deleting this Vault cluster resource from the old provider and adding it to the new provider. If we didn't do that, then we wouldn't be able to run our provider because Mux wouldn't know which provider was providing that resource. So in order to route the requests to the right handler here, then we've also added some kind of routing, I guess we call it, in the provider function itself. And now here in this file is the actual implementation of the resource in Terraform plugin Go. So this is what it looks like. So you'll notice it looks a bit different from the schema, the helper schema provider. We have essentially a sort of type we defined up here, which is a TF types type. TF types being part of the Terraform plugin Go packages, and this is defining all the attributes we can have on our resource. And here we have the schema. So that's looks fairly similar to the other schema. Okay, so your helper schema resources are using CRUD functions. So create, read, update, delete, as well as import. And those are not really a sort of true mapping to what the Terraform protocol is actually doing. So with plugin Go, we're trying to go a bit closer to that. And so you have validate resource type config. I'll go back to that in a moment, actually in the editor. Upgrade resource state, plan resource change, apply resource change. In fact, I think we probably want to go to the editor at this point. So I've got some highlighting here. Okay, yeah, please interrupt me if there's anything wrong with the font at this point.
No, it's perfect. And
great. Okay.
I like the colors. Sorry, go on.
I like them too. Yeah, okay, so the first thing to note here is that despite this huge file having appeared, we haven't changed any of our other files. That diff I showed you was basically it. We've removed our old implementation of this vault resource. We've added a new implementation in this file, and that's it. We don't have to change any of the other resources. We've just migrated one resource to the new plugin Go library, which we can use alongside the SDK. Now, in this validate resource change step, this is where we're able to do something you can't do in the SDK. And at this point, so if you recall, what we're trying to do is we're trying to check whether the region that the users put in the config is actually available. And our API, our HashiCorp API, gives us an API endpoint for that. So we can do something we couldn't do before, which is literally just call the list endpoint during validate. So we're going to take the region the user put in the config. We're going to check if it's a valid region. Sorry. If it's not found, we're going to return an error. So what this should mean is that you're able to make this network request during validation, which you couldn't do before. So. So you'll see us rebuilding the provider while we're doing these demos, and doing a number of steps, including go install. We're going to improve this development flow in Terraform 0.14, which will be released pretty soon, I am told. So that's pretty exciting. But if we forget one of these steps, then that's why. Okay. So. Now we've got the new provider. I've got it symlinked to the appropriate place in the file system. We can run this. And now we can validate our config. We can put in new regions. Validate our config. Paddy, was there some test change here as well?
There was not a test change. I mean, the test should still pass. That's the good news. But no, there shouldn't be a test change. But if you do a region that is not invalid, then it should break and let you know that.
Yeah. Oh yeah, sorry. So the actual kind of important thing here was that we have validated this region, and it is valid. It was not valid before because we were not able to make that request. So just to complete the demo, is that an invalid region, just to show that it doesn't validate as true every time. So that's the first resource. And yeah, let's go on to the second one. Do you think, Paddy, or was there anything else to say about this one?
I don't remember. There's a bright light in my face, and so I've gone deer in the headlights right now. So I'm literally just scrolling through a Google Doc right now, being like, "What were we gonna say?" I know I've spent like the last 24 hours worrying about this, but what was I going to talk about? Cool. I'm happy to jump to the next one. I'm going to just steal the screen from you. We're going to do that. It's going to be fun.
While you're stealing the stream, I was thinking about Vim. Vim makes me scream. Sorry. Apparently everyone other than me likes Vim, and yeah.
Like is a strong word. I like Vim the way I like Oxygen, in that I find it everywhere, and so it's convenient if it helps me out. Like that's my relationship to Vim, is like, I don't know that I call myself a Vim user so much as I'm like, no matter what machine I find myself on, I can always get Vim very easily. And so like I've got a very minimal Vim setup just so that I can always edit text on computers, because I feel like that is like, I always feel bad about myself when I can't edit text on a computer where I'm like logged into a server or something and I'm like, right, how do I edit this config file? And I don't know the answer because there's no Sublime Text or whatever for me. So back in college, I was like, nope, we're going to go to Vim just because it's the lowest common denominator.
I'll take that. I also shamelessly use the arrow keys. I know enough to escape Vim purgatory with my colon, my W, and my Q, and that is all I need to survive in life. But it looks like we are split down the middle in chat.
I use W, I use D, I use B, I use V, I use Y, I use P, and I use the curly braces. And that is, oh, and I use slash, and I use like the %S or the S when you've highlighted stuff to replace things, because most of my job is copy and paste and then replacing things. And
That's
so
fair.
yeah, that's the extent of my Vim knowledge. That's everything I got. If you want me to like fold a code block, I'm like, I don't know. Hit buttons until it works. I don't know. But cool. Back to the stream. Let's talk a little bit about another thing that's bothered me. This is basically when we talked about this stream and what we were going to do. We basically were just like, what if we just went through 4 years of Paddy getting frustrated at provider development, and then showed how Paddy won't be frustrated about it anymore as long as he's okay with typing a lot. And that's essentially what we're doing right here. So the next thing that really frustrated me for a long time is I wanted to be able to oh, I'm getting ahead of myself here. I wanted to be able to validate two different fields on a resource. So like if field A had one value, field B has, I don't know why I'm giving you hypotheticals. We're just going to actually look at the resource itself. That feels like a better way to do this, given that we've taken all the time to like write these up. Let's take a look at Terraform workspaces, because of course DadCorp Cloud would not be complete without its star product that everyone loves the most, because the people that work on it are just the funniest and most charming. The Terraform Cloud offering here. So let's take a look at this. Terraform Cloud at DadCorp has a neat thing where you can execute on agents. HashiCorp, being derivative, copied this from DadCorp, but it's also very exciting that we have it. And you should check it out using Terraform Cloud, which is the only business pitch I will give you today. Anyway, so we've got execution modes here, and you can use those for local, remote, or agent. Agent just means you're going to use pools of agent. Remote just, yeah, I don't actually know what the other ones mean. It's not important. So what is important though is that when you are in the agent execution mode, you can have an agent pool ID. However, when you are in any other execution mode, you cannot have an agent pool ID. And right now, that is a tricky thing to do with Terraform, which sounds silly, but that's the way it is. That is actually a deceptively difficult thing to do with Terraform, to the point where if I change this to remote right now, I hope I checked out the right Git branch. Oh, I should probably rebuild my provider. If I we're going to install that, we're going to move it, and we're going to go to configs, and we're going to remember to Terraform in it. And yeah, okay. So if I validate this, it's going to be like everything's fine, even though we just said everything is not fine, right? Because it's remote, it needs to be agent. That's not cool. And you can actually see it if you plan it right now. it's gonna be like, hey, you can't do that. That's not okay. And that's the best you can do at the moment with helper schema. That's the extent of the user experience you can provide. And that's using a hack called customized diff. And I say it's a hack. The actual customized diff behavior is not a hack. Our Sentinel engineering lead added it, I want to say a few years ago. It was mind-blowing that he managed to pull that off. I was very impressed with it. But it's not meant to be used for this. Like this isn't the point of it. And we're going to talk about what it's doing in just 1 second once I can remember how to open up files on my computer. So this is the function in question here. We're talking about the Terraform workspace resource, and we're talking about the customized diff function here. And customized diff is basically called when plan runs. It gives you the ability to modify the plan as the plan's being created. So that's the idea of customized diff here. And I believe it was created for that explicit purpose to actually modify the diff that will be presented to users. We're using it here just because it happens to run at plan time and we happen to know all of the, like we happen to get access to all of the fields available to us at that point. But so we can actually check like what the planned execution mode is and what the planned agent pool ID is. This is not the ideal way to kind of get this kind of validation for a few reasons. It doesn't run at Terraform validate, so Terraform validate is going to be like everything's great, but Terraform plan is going to be like no, it's not. The other thing is customized diff is just a very powerful tool, and there's a lot of ways that you can accidentally hurt yourself with it. I definitely worked on a bug where our improper use of customized diff made it so that we accidentally deleted and recreated resources on the user without telling them in the plan that we were going to do that, which is like the cardinal sin of Terraform, is destroying your infrastructure without telling you, because that means downtime. So yeah, so customized diff has a large blast radius. It's a very powerful tool. And it's not meant to be used for what we're using it for here. The only reason we're reaching for this tool is because it's got access to the information that we need, and it happens to run at plan time. Before this, we would have to actually just do this validation in the create function itself or the update function itself, which means you would get halfway through an apply, and then you would find out that your configuration is invalid, and like your infrastructure would be in a half applied state, and that's never good either. So we really try and avoid that. Unfortunately, we can't do this in the validation functions that we've been talking about, because the validate funcs only have access to the field that the validate func is on. You don't have resource-wide validation, you have field validation. There is good news, and if you've been paying attention for the last 50 minutes, you'll know where I'm going with this. You do have access to those things now. So if we check out, I need to get rid of all of my stuff here. So let's get rid of the, this is my fault because Katy definitely gave me a command so that I wouldn't have to do this anymore. And I thought I ran it, but I guess I didn't. And this is just why I can't have nice things. But so we're going to do that, and we're going to check out, I forget what I'm on. I think I'm on demo 4 now. We're going to hope so. Move Terraform MVO, Terraform workspace resource to plugin go. That sounds right to me. So if we look into internal provider Terraform, no, we want plugin Terraform, sorry. Plugin Terraform.co. We can see this is the same resource. Again, it's structured the exact same way as the Vault resource was. It's almost like we copied and pasted them. That's because we copied and pasted them. And it's got the schema set up here and all of that. What I want to show you is, once again, the validation stuff down here, this validate resource type config, because what's nice is you actually get the entire config here. So inside this config, we can be like, do we know what the execution mode is, and is the execution mode set? And do we know what the agent pool ID is, and is the agent pool ID set? If so, let's take a look at what the execution mode and agent pool ID are. And if we've got an execution mode that's not agent and the agent pool ID is set, let people know that's not okay. Let people know that at validate time, not at plan time. And also don't accidentally like hide a create or a destroy and recreate diff at the same time when you do it, because that's no fun. Users were not happy in that issue. That was a bad day. If we go back here, we remember to Terraform init. And if we update the terraform.tf, so this one's going to work. So if we take a look at Terraform validate, I mean, I hope it works. Yeah, it works. That's always nice when things work. And then we change it to something else. And we go ahead and validate that. I was like, hey, you can't do that. And notice how it's actually underlining exactly what went wrong. Customize diff, because it's for changing the diff, doesn't usually point to specific things in your resource. Like, it doesn't have that capability exposed because it wasn't what it was designed for. And that's kind of one of the flexibilities and tragedies of helper schema, is that we've got all of these tools available to us and they keep getting repurposed for things that aren't quite what they were intended for, but let us get the job done. And that kind of powers Terraform's growth, but also means you get weird workarounds and limitations. But this works exactly how we wanted it to. If we go in, and I haven't actually tried this yet, so we're gonna watch it live. It's gonna be fun. It's gonna be good. Let's see what happens. If we go in and validate that, it's valid again because I removed the agent pool ID. So that's the idea with that. Just checking that I talked about everything I was supposed to. Yeah, I think so. So I think I'm going to give the screen back to Katy, and I think we've got one more, and this is the one I'm most excited about. We've got one more resource we want to show you of a new pattern.
All right, while you're switching over, one, thank you for bringing up customized diff, because I had a note about that. I remember it was evil when I was working on the provider team. So I was going to ask you, why is it here? So thanks for going through that.
We couldn't possibly comment on what functions are evil in the SDK.
Valid.
I love
also,
all of my children equally, no matter how much they terrorize me.
Exactly.
Go on mute. Having Alex brought up something that might be good for a quick discussion, and it's relevant to what Katy was demoing earlier. So it says, having run into the issue, I think I should share this. When doing API calls from planned resource change, like Katy is awesomely doing, see, awesome. Now you'll want to think about where the provider configuration attributes are sourced from. When using other resources to set any attribute on the provider block, the plan and apply will fail if said resource is not already present in the state. So you would not be able to create it in the same apply.
I love that we've got our provider developers from HashiCorp in the chat, because they are absolutely here to call us out on all of the stuff that we thought we were going to be able to gloss over because people weren't going to notice. Yes, we did like in that the validation with network calls stuff, we did gloss over it entirely, where the provider authentication is sourced from by using an unauthenticated resource call. There's an entire complicated stream we could do about when values are available and stuff like that. We don't quite have time today to get into all of that, but yes, it is a good idea to think about. Terraform's a lot like a political scandal. It's a lot about, when did you know it is like the important question. When do we know what the provider's configuration values are? Because that's the whole idea of unknown being part of the type system here, is that there are a lot of times where Terraform's like, I don't know what this is. I'll know later. Let me tell you later. And you've got to kind of build your user experience around that, if that makes sense. But that's my bit there, Tracy.
No worries. I'm just going to put this out there. I know we said an hour, but if you all don't mind staying with us for another 10 or 15 minutes, we'll stay on so we can finish all this lovely demoing and work that we're doing, because I am absolutely enjoying this.
Oh yeah, we're going to get to the really exciting one now. I mean, validation is very exciting for everyone, I'm sure. But you'll be possibly pleased to know that the final example doesn't involve any validation. Actually, it does involve some validation, but just as a sort of bonus. Okay, so let's sort of frame this problem. So here we have the DADCorp access policy resource. And as I mentioned before, this is a way of setting an access policy on many of your products. This type can be Terraform or Vault or Nomad or other things that DADCorp runs on the DADCorp cloud. And the policy data, so in the old version of the provider built with the old SDK, this policy data is supplied. Essentially, there are a couple of ways of doing this. We see people putting strings in their config. Here you have a sort of workaround for that, where you've made an extra data source And then that data source basically just gets kind of put into this config attribute here. But the reason this has to be done is because policy data is going to be different depending on what the type of the access policy is. So if you had Nomad here, for example, you'd want to have different values here. And there's a limitation in the current SDK where you can't have a schema that doesn't know what your object attributes are going to be called. I mean, you can't do that. So this has been a pretty large limitation for a while, and we're pleased that we can now actually offer dynamic pseudotype in the schema. So the dynamic pseudotype is this sort of placeholder that Terraform has, where it says, I don't really know what type this is going to be, but that will be tolerated for now. So in the new implementation in Plugin Go of this resource, which I'm going to show you in a moment, we don't need this data source anymore, and we don't need to be putting strings in our config. We can actually treat this policy data object, despite the fact that its keys may change and the schema doesn't necessarily know what it's going to be. We can treat that as HCL. So if you see here, the user has just written this in normal HCL. It's not a string, and we can now sort of see into this and validate it as well. So if we take a look at the implementation for that. Okay, so the first thing you'll see is I've obviously changed the config. We don't have to have that data source anymore. I've changed all the tests. Some satisfying deletions here. I've deleted the data source implementations. That was also satisfying, lots of deletions. And here we have the new implementation of the access policy resource. So let's go and have a look at this in the editor, actually. So, I mean, this is similar to some of the other resources we've been showing you. It did require a bit of copy pasting. There's a lot of sort of shuffling types around here at the top, which there's no need to show you here. But I mean, the interesting thing here is that we've got a type for each of these policy data options. So the Terraform policy is different from the Nomad policy, for example. So in order to kind of parse all of these, we have to implement things like from Terraform 5 value. We have to translate between Terraform values and other values. Okay, so yeah, so the schema of this resource looks fairly simple. We've got 2 strings and a dynamic pseudotype. That's all you have to put in the schema. Now, one of the really interesting things you can do here, I promised you validation. You can now validate these values. So in the old version of this resource, the user can just put anything in here, and it's not really going to fail until the API responds and says that that's not a valid access policy key, for example. But that's only going to happen on Terraform apply if you're lucky. Whereas with the new implementation, I can hopefully show you the fact that Terraform validate will actually fail at this point. So yeah, let's have a go at that.
I love that Katy says, can hopefully show you, because we definitely were finishing the code for this like an hour ago. So
there's a lot of code. So I've initialized the new version of the provider. So let's just show what the plan would look like with the sort of standard config here. Whoops. Well, that was everything. I didn't bother to target it, but let's go and have a look at the access policy. Yeah, so I mean that's what we'd expect. We have this nicely displayed in the plan, because with Plugin Go, I mean you have complete control over what's displayed in the plan.
It's also worth noting that it's not a JSON string in the plan, I think. And so when you're doing stuff with and you can also like interpolate each of those individual values. That's just HCL in there.
Yeah, exactly. Yeah. When I say displayed nicely, I mean it's not JSON or a HIRDOC string or something like that. Yeah, okay, so let's try adding something that shouldn't be there in the policy data and that we ideally really want to validate. So, oh, it's valid. Okay, why is it valid?
Did you re-tag demo 5 after you fixed that?
Oh, no, you're quite right, actually. Thank you, Paddy. I only tagged demo 6, which is the version of demo 5, but with validation. Thank you very much. Okay, let's try this cycle again. So initializing the new provider. Oh, and now let's go and change the file again because I got rid of all my changes. Oops. And now when we validate, the error message is wrong, and that's presumably because I've just not actually told the error message what bit of the config it should highlight. So as Paddy was showing earlier, you now have control in these diagnostics basically of how the error is displayed to the user. And so it looks like I probably just haven't told it where to show the problem with the user, but that's exactly what it would do. And importantly, it has validated before it bothered to send a network request that there was an unexpected value in that dynamic config. So
and as with everything, as with everything Terraform plugin Go, more typing will solve that validation issue. We can just type a bit more and get it.
Yeah, I mean, there's a pretty massive amount of code here to go through. Yeah, I suppose it would be this, wouldn't it?
Oh yes, let's not do it live.
Very well, very well. Do we have anything else to say about this resource?
I think the only other thing to note about it is just that we're very excited about it because we're looking at rebuilding the HTTP resource in it, because not only can you accept anything in the config, you can return any response as HCL, like interpolatable data now. And so instead of having to JSON decode HTTP responses and stuff, when we rebuild the HTTP provider to use dynamic pseudotype, you'll be able to just reference subkeys in JSON automatically without needing to pass it through any functions or anything. And I think that's really cool. And I think we're really excited about the Kubernetes alpha provider, which is currently examining rebuilding it in top of Plugin Go so that it can use this to accept Kubernetes CRDs as input and apply them automatically because it doesn't know what the CRD's schema is, but it kind of opened up the door for that new use case of not having an actual schema and having Kubernetes enforce the schema for it.
Yeah, so dynamic pseudotype, like not only does it have a cool name, but it's quite a sort of big deal. So please go and read up on it if you're not familiar with it already. So as you can see, I've just changed basically one line, and it has now highlighted the appropriate part of the config, which is incorrect. Paddy, would it be possible to get it to highlight exactly the line that's wrong? Yeah, you basically just have to walk the path into the HCL, which is now HCL, and tell the user this is the key you've put in there that shouldn't have been in there. So we can get a better error message than this.
You would have to diff the different keys on the objects.
Yeah.
To be like, here's the object that it is, here's the object that I want it to be, what's the difference in the keys? Okay, highlight those keys and be like, those aren't supposed to be there.
Yeah, exactly.
Tracy, it sounded like you wanted to ask a question or say something. What's up?
No, I was going to say, you brought up the Kubernetes alpha provider. There was a Terraform deep dive yesterday that did exactly that. That's what the deep dive was about. I'm trying to find the link now to pop in the chat, but that was fun. That was Phil.
Yeah, No, we're super excited about. For us, the whole plug and go and plug and mux. The reason they're exciting for us, just looking at chat, is because it gives provider developers the ability to build better practitioner experiences. Right now, it's frustrating as a provider developer to try and build certain UXs to give practitioners a good experience in certain situations. And basically what we're trying to do is eliminate those constraints on people. So now if Terraform's able to support a user experience, you should be able to build it without having to like work around the helper schema framework. And it is the very first step in our kind of goals of making that easy and approachable, but it's a big one and we're super excited about it. I don't know if that was my impromptu random speech. That's what I got.
That's great. Yeah, I totally agree. I don't have anything else to say about this resource.
Cool.
Anything else people want to see in this provider? We're going off script now, Paddy. This is not in the script, I understand, but you know, we can give it a little tour.
Do we want to just run Terraform or Go test live?
Oh yes, I do.
Hope for it to pass.
Yeah, that'd be a good one to take us on.
I mean, we can even run Go test -v, so we see all the tests, I guess.
Yeah.
I like seeing the ones that pass, not just the ones that fail.
Also, because then people will think that we actually have test files.
We absolutely do. Yeah, so these are, apart from the config in the test I changed, these are the same tests as you had before. So when you put a plugin Go resource into your provider via plugin mux, you don't have to rewrite your tests, which I hope you'll be happy about because no one likes rewriting tests.
No, they don't.
Awesome. Do we have any questions? Anything people want to talk to us about?
Oh, don't forget to talk about how active you all are in Discuss while we're here.
Oh, we are active in Discuss. It actually, if you post in the Discuss forum, the SDK, I feel like I'm echoing. I don't know why I'm echoing. I feel like, is that my fault? It's probably my fault. If you post in the Discuss forum, it actually goes right into our team Slack channel. The Discuss forum is something that we're trying to pay a lot of attention to and trying to kind of set up as a support resource for provider developers. So definitely check that out. Let us know what you think. Let us know if you have questions. Tell us about the interesting things you're building. We're excited to hear from you there, and you can find other Terraform provider community members there. That's what I got. That's my pitch for Discuss.
That's your pitch for Discuss. All of the tools have a Discuss forum. So definitely if you have any feedback, if you have any questions, if you want to ask a question about an issue that you're having, definitely post it there. Engineers are in there, PMs are in there, other practitioners are in there, and I'm 9 times out of 10, you're not the only one having whatever issue you're having. So definitely go in there. Is there anything else that we need?
I struggle to keep up with it, but like I try and at least like once every couple or few weeks go through and literally just answer every question and discuss and just circle my way through. It really depends on, you know, how much of this and how many new projects we're shipping, but that's a thing we like to do.
Before we get off of here, I did miss one. Let's see. Oh, okay. I think Tony and HashiCorp Live have both responded to that. We are making a note of it, but it said it would be good to see development of custom Vault plugins. Also, the push for partners to develop Vault plugins is not the same as Terraform. JFrog recently has a mature Terraform provider, but this particular user could have really done with Vault creating short-lived OAuth tokens. So we have made a note of that in at least 3 places right now, and I'm looking at one that's not even related to Twitch. So definitely know that that will be taken into consideration, and we will give that feedback. Any more questions? Last call for questions. This has been fun. We got to do this again.
Vault plugins. There, we got 4 now.
Number 4. All right.
I mean, I can give some sort of insider information on the Vault plugin thing. I was actually talking to the person in charge of Vault plugins, and they're interested in the approach we've done on Terraform. So the lessons we have from Terraform plugin development will definitely be applied to Vault plugin development, because we're all talking to each other about it. So we can't give timelines or anything like that, but like it's being actively thought about.
Okay.
I think after seeing your terminal setup today, everyone's just very interested in your approach to everything, Katy. I feel like you've established yourself as a trendsetter with your terminal setup.
My dot files are available.
Oh, I'll hit you up for that when we get off here. All right, we don't have time to talk about Paddy's pies, but I will bring him back soon for that discussion. Also, you will hear more from this team. We're going to have an office hours. You get to meet Tony face to face that time in January. So be on the lookout for that on our community page. And I'll also be speaking with another part of the Enable team. We'll talk a little bit more about the language server, which you all have been jumping on us about. You'll get to hear more about the what's and whys of that in the office hours, also hopefully in January. Katie, someone wants a link to your dot file. We'll see what we can do if we're going to make that publicly available. I'm also going to talk about seeing if any of the demo is publicly available. So keep on the lookout. Thank you all for coming. We will not have one next. Let's see, our next HashiCorp Live, here we go, will be on December 4th. So keep on lookout on that and find out who our guest will be then soon. Thank you both for being here. I miss you.
Thanks so much for having us, Tracy. This was super fun.
Thank you, Tracy.
You're welcome. All right, see you all next time.
Have a good week, everyone.